Well, we are having right now a tech talk on rethinking cybersecurity when your workforce is remote. Well, we have with us Lee Dolsen, the Chief Architect, Asia Pacific and Japan, Zscaler, Singapore. Lee is a chief architect of the Zscaler's Asia Pacific business based out of Singapore and has more than 20 years of experience in the IT industry focusing on various aspects of internet security and content delivery. Lee has been living and working in Asia for the past 14 years, and he joined Zscaler in 2012. Thank you so much, Z, for joining us, Lee, for joining us today.
Thank you,
Over
Bhavana.
to you.
Thank you. Let me share my screen. All right, thank you, everyone. Really appreciate the time to get a chance to talk to you today and go through some of the things that we've been seeing. COVID-19 is really changing how organizations are thinking about digital transformation. We really see it accelerating digital transformation. These are trends that were already in place, and I think part of why COVID-19 wasn't necessarily as huge an event for managing remote work is because there was so much SaaS adoption of technology. But it is really causing people to rethink about what does the future look like. There's been a number of surveys of executives talking around remote work. Majority of employees in the majority of the countries have gone home and have continued to work at home primarily for the last few months. I mean, I'm sitting in our office to do this webinar because it's an empty, great place to do a webinar. But we have all this real estate that's empty. And when surveys, executives have been surveyed, the vast majority have stated that things will never go back to normal in terms of where users are working from. There will be some percentage, and depending on the type of organization, varying percentages of employees that will come back, but it will never go back to the pre-pandemic scenario. And so that's driving also, business continuity in the terms of not just traditional business continuity, thinking of what do I do if a data center goes down, or what do I do if a particular person is unavailable, or the sort of standard things. And it's really thinking about business continuity on many more levels. What does it mean when I have the majority of users working from home? What does that mean from a costs of operating the business when there's real estate and network costs and so many costs that were accepted as standard costs in the past, but suddenly looking at being able to make sure the business can survive and thrive in this new world, what of these costs make sense? And so that's driving organizations to even more rapidly change their culture. A lot of the challenges we've seen with digital transformation have really been around internal cultural changes. I mean, collectively as an industry, we've been doing things in a certain way. We've grown up in this world the last 20 years, building things in a certain way. And SaaS and cloud is actually a radically different way of doing things. It requires cultural changes. But what we see is, organizations taking advantage of this event to more quickly change their culture, adapt, make the right changes that make sense to live in this new world. And so what does that mean? One is this legacy way of doing things doesn't really work. So if you look at the center of the screen here, we've got this, historically, this is what we've been building for the last 20 years. You've got your data center, you've got your offices and different things hanging off that data center. And the idea was you would bring your users into that data center, into the office, and they would connect over a private network to those applications. And then you would have, a bunch of technology doing security if users go out to the internet. And then other technology around, those edge cases historically where a user needs to come and they're at home, they're in a remote network, they need to get into the data center. And the idea has been, okay, let's use VPN technology to bring them virtually back into the data center. And so I'm still inside the castle and inside the moat. But that represents a lot of challenges, especially when we move to this model of all the users working remotely. So you have a bunch of challenges there. Number one is the basic security challenge of the castle and moat model being really fundamentally flawed. The idea that we can trust a user just because they're inside the network is really fundamentally flawed. We see majority of the successful attacks that happen are because a user gets compromised, whether they're inside the office or they're accessing via remote VPN. And that attacker is taking advantage of the castle and moat model then, because that endpoint is a trusted endpoint inside the castle, has lateral access to the entire castle, to the entire stack of all the different applications that are inside that data center. So it was a flawed model from the start, but when you add this into a 100% work from home, you've got this other challenge where we see majority of organizations were not applying the same security controls that were sitting inside the network. They weren't, those controls aren't necessarily being applied when a user is at home. And it depends on the organization. Some more sensitive to security organizations will be forcing like what's called a full tunnel to route, all of the user traffic from the home into here and then trombone it back out. But for organizations that have been doing that, that's a huge challenge, because suddenly you had VPN infrastructure and internet infrastructure that was sized for maybe 10, 20% of your workforce, occasionally working remote, until now we're in this land where we're 100% working remote or 80% working remote, and that's not going to be changing dramatically anytime soon. So VPN scaling issues are huge. You still have that, kind of a lot of the fundamental challenges. And what we see more organizations are actually doing, those they're relying on the endpoint security only, and users are actually, all the internet traffic is actually going direct to the internet. It's only data center bound traffic that comes back over this VPN tunnel, which represents even more risk, because now you don't have whatever security controls were in the data center protecting those endpoints. It's whatever is on that user's home internet, which, let's face it, is probably nothing in the majority of cases. So you're relying only on what's on that endpoint's software, giving attackers really a lot more access to control those users and then get lateral access into your network. So it's a big challenge doing it the traditional way. So in terms of what we've seen organizations look at, some of the strategies to try to manage this, one option, everyone likes to go with what they know. So we're used to building out these stacks of firewalls and security appliances. And we can build them in a virtual form factor, and we can build them in AWS or build them in Azure or Ali Cloud or GCP, wherever you might want them based on your preferred cloud infrastructure as a service provider. But that's a very challenging way to do it. Ultimately, when you're building it that way, you're increasing the complexity of the on-premise DC. You're increasing that further. The cloud providers, while they're providing you SLAs around the uptime of their infrastructure, they're not providing you SLAs around all the complexity of the interconnectivity that you need to manage across all this. And when you're leveraging one of these cloud providers to then connect onwards to other cloud providers, the other thing you have to recognize is these guys compete with each other. So if you're using Office 365, but you've standardized on Azure, Microsoft and Amazon don't have any real compelling reason to make sure connectivity between their networks is really good. So you want to look at a different approach, really. You don't want to manage all the different things you've been managing physically and just expand that virtually. It's just creating more to manage. As you see the one note there, it's something Jay might have said in that video, is it's like stacking DVDs. Netflix would not be where it was today if they took their DVD mail-in service and said, let's take all these DVDs, let's put them in DVD players in a data center, and we're going to build the Netflix streaming service that way. That would have never worked. And that's equivalent to doing that if you're trying to take virtualized appliances and put them in a virtual DC. The model that we're talking about is a cloud native, built from the ground up, to be agnostic to all the different SaaS and infrastructure service providers, where it is pure SaaS. It's like an ocean. Users can connect to whatever the nearest resource is. There's POPs all over the world. It's built to support 100% mobile workforce. I mean, it doesn't. It's been built at a user level from the start, and where those users are coming from is just an input that's leveraged for policy. And then it has peering and seamless connectivity across all the different SaaS and infrastructure as a service providers. So it's giving you a very comprehensive security stack. It's removing the attack surface because you don't need to actually open up any of your own data centers. This model on the left, that's also putting traditional VPN, traditional attack surface type things into those cloud data centers. So you're expanding your attack surface as well. And so the way we do this, we've actually broken this exchange really into two different sides of the house. The one piece of this is, as your users connect to public internet, public SaaS, external apps that are not built by you or not being hosted by you, whether it's hosted by physical or virtual infrastructure. They're being hosted by SaaS providers like Microsoft, like Salesforce, ServiceNow, et cetera. Those are all publicly available. And that's where the rest of the internet is. The internet in general is publicly available. This is where we see all the threats coming from, is that generic internet. So this is doing all of the internet inspection. It's doing SSL inspection at scale, all the security inspection as users go out and connect to external apps and bring content back down to their endpoints. But likewise, on the remote access piece, rather than looking at this from a pure remote access perspective, we're looking at this as a ZTNA perspective, zero trust network access, zero trust application access, where users will connect to the cloud, they're strongly identified, and then we're brokering that access to internal apps, whether they're hosted in AWS or Azure or some other infrastructure as a service provider, or hosted in your traditional DC. It's agnostic to where the applications are hosted, but it removes all inbound to these locations where you're hosting these apps. So that's Zscaler private access. So like I said, at the start, what we're seeing is this is really then accelerating this concept of moving from the castle and moat model, where I'm always thinking about bringing a user back into the network, and we're moving to this zero trust exchange. And it goes beyond employees too. If you think about all the different use cases where you have users or servers or IoT or OT that are leveraging internet to connect to things. You may have OT connecting to infrastructure as a service. You may have IoT connecting to trusted third parties in the internet. You have customers coming into your applications in different places. You have your own employees, you have contractors. And so there are many, many different flows and different use cases where this zero trust exchange can be leveraged to give you seamless access regardless of where the user is or where the server or the application is. So let's talk a little bit about the security. And this is just an example here, a particular threat that our Threat Labs team saw. But we actually saw, you go to our Threat Labs blog, if you Google Zscaler Threat Labs, you'll quite quickly find our blog. A lot of different interesting things we've found. And this is one of the challenges when users are working from home. Any of the security that you would have had to detect these sorts of threats isn't there. You're relying purely on the endpoint software if you're not backhauling those users to your traditional security stack in your data center. But what we saw specifically with COVID, because there were so many eyeballs, especially in the early days, on this topic globally. I don't think, since the history of the internet, I don't think there's been one topic that had so many global eyeballs looking at it. And of course, the bad guys took advantage of that. We saw a 300,000% increase, so just a massive, massive increase in the number of threats specifically related to COVID. Social engineering attacks, copies of the Johns Hopkins dashboard, hundreds of thousands of domain names registered to attack users based on these new social engineering attacks. And these were all rapidly discovered by the cloud. We used machine learning, we used sandboxing, we used all the different security technologies to automatically detect these things and protect users and organizations from these threats. So if we talk a little bit more about what Zscaler Internet Access is doing, the basic idea is no matter where the user is coming from, whether they're coming from home or they're coming from your physical offices, they're coming from a factory, the idea is we're going to be routing all of their outbound internet traffic up to the Zscaler cloud. At that point, the Zscaler cloud is going to block any requests going out to bad destinations or any content that is bad as it's coming back and users are attempting to download that content. But it's also looking at the content users are uploading, where users are uploading it to give you controls from a cloud application security broker perspective. So it's doing firewalling, it's doing URL filtering, it's doing QoS, it's doing DNS security, it's doing very advanced, sophisticated threat prevention. We're doing sandboxing, detonating active payloads in the cloud. We're doing full SSL inspection, which is really critical. And I still see so many of the organizations I work with that are not doing SSL inspection because it's too hard. And the thing is, majority of the threats, the majority of the internet these days, it's roughly 80 to 90% for most organizations, is encrypted over SSL. And the bad guys, they're encrypting their traffic over SSL because they recognize that a lot of organizations, that's a blind channel for their existing security stacks. So we're providing these SSL controls, and then we're looking at all the data protection controls as well. So doing DLP of the actual data as users are uploading it, doing CASB, file type controls, application controls, and also giving you global visibility into all this activity, no matter where the users are, whether they're working from home, sitting in your office. This can be globally integrated into your SIM, into your SOC, and you've got one pane of glass to see where all this activity is globally. Now, if we talk about the internal applications, we're really flipping this idea on its head too. So, the original idea of the internet, I like to say, was invented by Star Trek fans. They assumed we'd be living in a utopia. They designed this model where anybody can call anybody. And they do. Just like we see spam phone callers in the phone world, we get attackers trying to connect to any other endpoint. And it's not good. There's no inherent security in the way the internet was built. It was built on any endpoint can connect to any endpoint by default. You've got to add security on top of that, and it's very hard to build that in a very clean and effective way. So if we rewind phones, to the early days, there was this idea of a switchboard model. And of course, this is before phones got very sophisticated. But it was also great if you think about it from a security model. You basically, as a caller, you'd call up to a switchboard. That switchboard operator would actually check your contract to see, are you able to even make this call? And only then would they actually physically stitch the cables together. They'd literally plug in cables, of course, in those days. Not something we want to go back to from that perspective. But what if we can take that to a cloud model where the cloud itself is the switchboard? So I can identify who the user is. I can do strong identification of that user through IDP, through posture checking, various criteria, identify who that user is. And the cloud then can, based on that criteria, say, okay, this user has access to this application. I've got another side of the switchboard, another switch sitting up in the data centers where the apps are hosted. And just like that old switchboard operator, that cloud is building, plugging in two connections to bridge that user across. So I've never allowed the user on that remote network. They're only connecting to the cloud. So if we drill a little bit deeper into this, again, the idea user could be anywhere. The idea with zero trust network access is we're moving to a zero trust model on the network side. It's really application access. So it doesn't matter where the user is. Identity is essentially the new perimeter. So they connect up to the cloud. We're connecting them to the identity provider, doing multi-factor auth there, doing fingerprinting, posture checking of the device, and then making decisions based on that user level and that posture check. Are they allowed to access? So there's no inbound access to your network. You see that blue plug connector that's in the top of the diagram. That's we're going to go into more detail on that in the next slide, but this is connecting out to the cloud. And so this is very different from traditional firewall or VPN. It's talking about anti-firewall and anti-VPN, you can see there, because we're doing all of our rules based on user to application. We're not doing network segmentation rules like we would do on a firewall. There is no inbound access to your network, so we don't need traditional VPN. It's anti-DDoS because, again, I have no attack surface exposed where your applications are hosted. So, DDoS also isn't required for the applications behind the service. The only inbound access is to the Zscaler cloud. But this is also doing other great things like giving you visibility to the internal application landscape, giving you visibility into health monitoring, path selection, a lot of different things to make it easier to deploy apps globally. And then finally, based on where the user is, what the type of device is, giving you potentially multiple levels of access. Maybe it's a BYOD device that I want this user to be able to do their job, but I don't want this device to connect natively to my app, leveraging technologies like browser isolation to render that user's experience in a container so that essentially you're in control of the endpoint. So many different ways this can help secure your users' access to applications. So next level of detail in terms of how this works, essentially what we're looking at is we're authenticating the user, we're enrolling that user with an IDP. If it's a managed endpoint, we can deploy an agent there. It's the same agent we would use for Zscaler Internet Access, so it's a shared agent across these technologies. So for managed endpoints, we strongly recommend this agent, which can do additional fingerprinting and posture checking. But if it's a BYOD device or a third-party contractor, this can also be done via a browser natively. So at that point, the user is identified, they're fingerprinted, and they want to connect to an app. So they attempt to connect to the app. They connect to it just like they would normally connect to it. They either go to the application in their browser, or if it's some kind of FAT client, they open up their FAT client. The cloud sees this attempt to access the application, checks based on this user's device posture, based on their identity, are they allowed to access this app? And you'll see in the data centers, you see that blue plug icon in each of these data centers. If the user is allowed to access, the next step is, where is the app hosted? Maybe I'm hosting it in my traditional DC. Maybe I've moved it to Azure or AWS. So what happens is the cloud says, okay, this user is able to access it. It then queries these connectors to say, hey, who's got access to this application? And if multiple connectors have access to it, it will determine the best path. So in this animated example, we see the best path for this particular user in this particular application was in AWS. And so we've then built a connection from that connector outbound to the cloud. So it's 2 outbound connections to the cloud, and we're stitching that user traffic across those 2 tunnels. So it's fully encrypted end to end. It's verified from a cloud perspective, verifying both the user and the connector to make sure there's no chance for a man in the middle, and doing very, very granular security this way. Full segmentation, because everything is purely user to application. I've never allowed that user onto the remote network like is done with traditional VPN. So that's how ZPA works. So a little bit about Zscaler to wrap up. We've been doing this now for over 10 years. Accelerating very rapidly in the recent years because of the growth with digital transformation, and especially just in these last few months with COVID, seeing a lot of interest from our customers. We've been a Gartner leader for multiple years. We're seeing, actually, this particular slide is a little bit old. We're at 150 billion transactions a day, what we see from a cloud scale perspective. So we've been doing this for a long time. We'd be very excited to talk to you more about this. We've got a booth here. You can go there and reach out to our team there. And thank you very much.
Thank you so much, Lee, for joining us today. And what an incredible presentation that was. And once again, a big, big thank you, Lee.
Thank you. Thank you, Bhavana.